The next question, or the next part of the question, is about a bicycle dynamo. So this is electromagnetic induction, and it's moved on a little bit to how electricity is produced on a continuous scale. So a bicycle generator or dynamo uses a rotating magnet. So there you've got your change in magnetic field. It's turning, the direction's continually changing. If you have a coil nearby with a piece of wire there, then you're going to have a current produced in it, and it's going to be alternating. Every half turn as that rotates around, there's going to be a north pole here, and then there'll be a south, and then there'll be a north, and so on. You're going to get a current flow in one direction, then the other, then one direction, then the other, and so on. And that produces an alternating current. So the first bit of the question says, sketch on the axis below how this alternating current varies with time. Now, we always draw an alternating current as if it was a sine wave. As long as you have it going one direction and then the other direction, then you will get that right. So even if it's not a perfect shape, so we'll just draw a nice sine curve. And you usually draw at least two complete waves there. So positive, negative, positive, negative. And then it says, explain how alternating current differs from direct current. And so you're going to get your 3 marks there, 2 marks for explaining alternating current, 1 mark for explaining direct. So if you do alternating current first, you have to get across the idea, first of all, of a direction, shift in direction, and that it's continual. So 2 things. So it's current which continually changes direction or repeatedly changes direction. So the continually will get you 1 mark, and changes direction will get you the 2nd mark. I would always put in there from plus to minus. You could also put to plus again, of course. And then your 3rd mark then is explaining DC. Current always flows in the same direction. Okay, and that's your 3 marks. Part D of the question then moves on to talk about the national grid and how alternating current is transported across the national grid. So you've got a power station, you've got a little box, and that little box, of course, is your transformer. You've got 2 pylons shown here and the cables across the pylons. So that's representing the electricity being transported across the national grid. Explain how stepping up the voltage in this way reduces energy losses in the national grid. So we know that stepping up voltage reduces current. Reducing current is going to reduce energy losses in the wires. And this is the whole reason that the voltage is stepped up in the first place. So what you need to say in there is that when you decrease current, I'm just going to write in here by stepping up or increasing. And then that causes less energy lost. As heat. Now where does the heat go? The heat just goes straight out into the atmosphere and it's just completely lost, it's wasted. So what they do is they decrease the current. That means they have to increase the voltage. And that means less energy is lost as heat. So there's your 2 marks. Decrease I, less energy lost. The next question is a transformer question. A transformer steps the voltage up from 25 kilovolts to 132 kilovolts. The primary coil in this transformer has 2,000 turns. So your equation, I'll just write it at the side, but it's almost easier at times if you don't use the equation. The equation is going to be your primary voltage over your secondary voltage is equal to the number of turns in your primary over number of turns in your secondary. Now, a lot of people will find this much easier to do it as a ratio idea. So the ratio of the voltages, it's stepped up, so the primary must be the 25 and it's stepped up to the secondary is 132. So 25 kilovolts to 132. I don't need to write down 1,000 there because they're both in kilovolts. So if you put 3 noughts here and 3 noughts here, you'd just be cancelling them anyway. Now, so then you can see 25 to 132. And if I just work out that ratio a minute here, I should have done this previously, but I haven't got it done. Divide by 25. And the ratio is 1 to 5.28. Now that means then you should have the same ratio of the number of turns. So you have 2,000 turns to what we don't know, the number of turns in the secondary. And so you have to multiply your 2,000 by 5.28 to get this number. And the answer is 10,560. And that's 4 marks in total. Now you'd get 4 marks for your answer. You would get a mark for your, if you didn't have your answer, you'd get a mark for your equation. You'd get a mark for putting all your correct numbers in. And then you would get a mark for maybe working out a ratio, 4 marks then for 10,560. Okay, this is the last part of this question. A magnetic field is created by passing a current through a coil of wire. On the diagram below, draw a maximum of 5 magnetic field lines. So it says a maximum. Now we always say draw a minimum of 3. To show the shape of the magnetic field produced, label the polarity of each end of the coil and the direction of the magnetic field lines. The arrows on the wire and the windings show the direction of the current flow. Now we find that this question is one of the most poorly answered questions, that people are very unsure about how to draw in particular the shape of the field. So the shape is very like that of a bar magnet, but you must show the lines through the middle. So there's always one complete straight line right through the middle. And you draw a minimum of 2 loops, one at the top and one at the bottom. And they also go right in through the centre. Like that. And like that. So there's the shape of your field. Now you would get 1 mark for that shape, and you can see there's 3 available. So the next thing you have to do there is work out the direction of the poles of each end of the coil. So you can see your current's going up the back and coming down the front. And if you use your right hand grip rule, you have to put your hand up under the back and down the front, and your right hand thumb points to the north pole. So this is a north pole and this is a south pole. Last thing, so that's your second mark. The last thing then is to show the direction of the field lines, and the field lines go from north into south. So out of the north, put an arrow on each one, and back into the south, put an arrow on each one. So there's your 3 marks. You've got a mark for the shape. If I write it up here, maybe you can see it better. The shape gets you a mark. The poles correctly shown gets you a mark. And the direction on the field lines gets you a mark.